Hi guys, so here we go. We're going to go around the unit circle again, around a circle, measuring all the angles and looking at them in radians this time. Okay, so please remember we have always have to start measuring from that positive x-axis. So this is our beginning and positive angles go in the counterclockwise direction. Okay, now first thing to remember is our equivalency between degrees and radians. So we know that 360 degrees is equal to 2 pi radians, or 180 degrees is equal to pi radians. Okay, so we could even divide this again. Okay, we divide both of those sides of that equivalency by 2. We would get 90 degrees is equal to pi over 2 radians. We could do that again. We could divide both of those in half again, and we would have 45 degrees is equal to pi over 4 radians. Okay, so there are lots of equivalencies we can get here. Then, if we start back at this one, 80 degrees equals pi over 2, and we divide both of those by 3, 180 degrees. I might have said 80 there by mistake. 180 degrees equals pi radians. And we think about this first circle we have here. Here's 180 degrees. I have then divided that 180 degrees into 3 equal sections. So let's divide this by 3, divide that by 3, and we can see that 60 degrees is equal to pi over 3 radians. Okay, so just a reminder that notation for radians, we don't just use an R, because in math that means radius in formulas. We can use the word radians, we can use RAD, or we could use this little symbol. It's a little C up in the same position as a little circle for a degree would be. Okay, so let's take this out of here. So in this first circle, each of these sections is 60 degrees, which is the same as pi over 3. So let's think about that. As when we did the degrees, we did, okay, this first one is 60 degrees. Let's add 60 to that. That gives us 120. Let's add 60 to that. It gives us 180. Okay. Now we need to be able to think in radians as well. So let's do this in radians now. The exact same procedure though. Okay, put my lines back in there in black. Okay, so these are 3 equal angles around here up to 180 degrees, or 6 equal angles all the way around the circle, 360 degrees. So each of them is pi over 3. All right, so from here to here is pi over 3 radians. This angle here is also pi over 3. So we can add pi over 3 to pi over 3. Pi over 3 plus pi over 3 equals, adding fractions, add the numerators, keep your denominator as long as it's a common denominator. That's 2 pi over 3. Okay, so 2 pi over 3. Add another pi over 3, we would actually get 3 pi over 3. But we can simplify that. 3 pi over 3 is equal to pi. Okay, so we won't write it as 3 pi over 3. Instead, we'll write it as pi. So get rid of that. Okay, write it in its simplified version. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. But we can reduce that fraction. 6 over 3 is 2. So we won't leave it like this. We'll write it as 2 pi. And I forgot to put 0 in here as well. So we should have 0 radians as well. So starting from here, 0 radians, pi over 3 radians, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, and 2 pi. All right, let's go to our 45 degree angles. We said that 45 degrees is equal to pi over 4 radians. Okay, so each of these angles is meant to be pi over 4 radians. It's not drawn to scale. I did my best, but each of these is meant to be pi over 4. So again, where do we start? We must start here. And for positive angles, we're going in this direction. Okay, so first one, pi over 4. That's an angle of pi over 4. Second one, add pi over 4 to pi over 4, 2 pi over 4. Okay, 2 pi over 4, we can reduce that fraction. It equals pi over 2, so that's how we will write it. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, I'm just going to leave it there for now and keep counting, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and again I forgot to start with 0. Okay, now can any of these fractions be reduced? Yes, they can. So this one can be reduced. That equals pi, so we'll use that instead. Get rid of this. This one's fine. 6 pi over 4 is actually equal to 3 pi over 2, so that's what we'll use. We'll get rid of that. And 8 pi over 4 is actually equal to 2 pi, so again we'll use that and get rid of that. Okay, so around and round that circle again. Down here, our final one. Each of these from the degrees was 30 degrees. Okay, so 30 degrees. So our equivalency, remember, 180 degrees equals pi radians. If I want 30 degrees, that means I'm dividing this by 6. So 30 degrees has to be equal to pi over 6 radians. Okay, so each of these is meant to be pi over 6. So here we go. Same starting point. We must begin here. And for positive angles, go this way. Okay, so first one, pi over 6. Add a pi over 6 to that is 2 pi over 6. I'll come back and do my reducing fractions later. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Again, I forgot my 0 if I start there and go nowhere. Let's reduce the fractions. So, I'll use a different color this time. 2 pi over 6 can be better written as pi over 3. 3 pi over 6 better written as pi over 2. 4 pi over 6, better written as 2 pi over 3. 5 pi over 6 is good. 6 pi over 6, better written as pi. 7 pi over 6 is good. 8, that's an 8. 8 pi over 6, better written as 4 pi over 3. 9 pi over 6, better written as 3 pi over 2. 10 pi over 6, reduce the fraction again. 5 pi over 3. 11 pi over 6 stays. 12 pi over 6, again, changes to 2 pi. Okay, so there we have it, all the way around the unit circle. You'll notice that some of these values are in here. Pi over 3, yes, that's because pi over 6 plus pi over 6 equals pi over 3. I just separated them into 3 separate places because these are all special angles in our unit circle. Once we build our unit circle, you'll see. And I want you to get used to seeing them. 45s is also a special place. So 45s, 30s, and 60 degrees are all special places on a unit circle. It gets a little too messy if you try to put it all together in one circle, but it definitely can be done, and you'll see that it can be done later on. Okay, have fun.